Welcome to the Lab-02 data types in assembly language. In this lab, we are going to practice declaring and manipulating variables in assembly language programs and understand the size of different types of variables so that we can store them in the corresponding registers and also verifying the outputs. Assembly data types have certain limits on data types, like if we have a byte type of data, it will take 8-bit to store them in register. If we have signed byte, it is also 8-bit, but this type of data is signed. And word, S word, D word, S word, F word, Q word, and different type of data types we are going to use in assembly language. In exercise 1, assemble and run the following program. Let's do that. This is a simple program. This program adds and subtracts 32-bit unsigned integer and stores them in a variable. Here we have three variables. Value 1, its data type is D word, which is 32-bit, and we have assigned it this value. And value 2 is also D word type, and value 3 is also D word type. We have three different values to these value 1, value 2, and value 3 identifiers. And we have a final value identifier which is D word type, and this is uninitialized. We will use this identifier to hold results. After dot code block, we will start writing our assembly program. This is main procedure, and its first instruction to move EAX. Value 1 will be moved to EAX, and value 2 will be added into EAX, which already contains value 1. Then we will subtract value 3 from addition of value 1 and 2. And the final result will be moved to final value. And call dump registers, it will display the registers. Let's build this program, and after that we are going to execute. And we have 30,000 result in EX register, which is expected. This program is adding and subtracting D word type values which are of 32 bits and storing result in different registers. The code is using EAX register to maintain the as only 32-bit registers can store 32-bit data value variables. Let's run exercise number 2. These were the result of running the program listed here. The final answer is stored in EX, which is 30,000 hexadecimal number. The content of registers EBX and ECX are garbage values. Since our code is not concerned with those registers and no value has been passed to them, so let's ignore them. In exercise 3, we are going to write the code to achieve the following. Number 1, define two 8-bit variables, variable 1 and variable 2, and initialize these to 20 and 30. Swap the contents of variable 1 and variable 2 variables using registers. Display the contents of registers. Since we are using 8-bit registers, the value should be byte type, that is also 8-bit. We will initialize registers EAX to 0, EBX with 0 and ECX also with 0 to avoid any garbage values in these registers. We will move variable 1 to AL of EAX. AL means the lower 8 bits of EAX, and then we move variable to BL, which is also the lower part of EBX registers. Then we move AL register value to CL registers, and values here we will swap the values. We will move the value of BL into AL, and then we will move CL into move BL. After swapping these values, we will call the function dump registers. Let's run this code in Visual Studio. After executing this program, you will observe that the contents of EX and EBX registers this code is dealing with byte 8-bit type variables which are stored in different registers and then swapped using third register, which is temporary, just to store value of one register so that swapping could be possible. We added 20 to AL register and 30 to BL register, but from the contents we can see that AL contains 1E, which is equal to 30, and BL contains 14 hexa, which is equal to 20. This is done using a third register CL, hence the swapping has been performed. In exercise 4, write codes to evaluate the arithmetic expression 5 plus bracket 6 minus 2 bracket by using one register. This program will move 0 into EX register. It will clear the garbage value in EX register. Then we will move 6 to EX register, and then we will subtract 2 from EX and add 5 to EX register. After that, we will call dump register function to display the contents of the registers. Let's hit the execution button, and here you can see we have value of EX is 9. First we clear garbage value from EX, then we move 6 to EX. After this we subtract 2 from EX, and finally we add 5 to EAX, gaining our final result, which is 9. Note that here EBX and EDX are showing garbage values and has no connection to the code. If we want to clear these values, we need to initialize these registers with 0. The next part is we have to evaluate this arithmetic expression 5 plus 6 minus 2 using only 2 registers. To solve this problem, we will include a 132.inc library to our code. Then we will move 0 to EX, 0 to EBX. These two statements will clear the garbage values in these two registers, EX and EBX. Then we will move 6, this value, to EX registers. and then we will move EBX, we will move 5 to EBX, and we will subtract, we are going to solve this part of this expression. We will subtract 2 from EAX register, which is having 6. After this part is solved, we are going to add the result of this bracket into this part. To do so, we will add EX and EBX registers, and we will call dump register function to show the results, and we will get the correct results. In the above program, first we clear the registers EX and EBX of garbage value, then we move 6 to EX register and 5 to EBX register. After this, we subtract 2 from EX register. Lastly, we add contents of EBX register to EX register and get 9 as answer. In Lab 2 of Computer Organization and Assembly Language, we learned how to declare and manipulate variables and store them in the same size of register. That is, variable of specific bit size need to be stored in register of same bit size. We learned how to create programs performing certain functions such as swapping, adding, subtracting using 1 and 2 registers. It helped us to get a better and deeper understanding of the assembly language.